some more word problems that are using natural exponential functions. Number one, the number of bacteria in a certain population is predicted to increase according to a continuous exponential growth model at a relative rate of 4% per hour. Suppose that a sample culture has the initial population of 45 bacteria. Find the population predicted after 6 hours according to this model. So our growth or decay models follow this formula right here. P equals P naught e to the kt, where P naught is the initial population and K is the rate at which the population is either growing or decaying. So for us, P naught is 45. K is 4%. As always, we cannot do calculations with percent. We have to divide by 100 to get a decimal. And then T is 6. All you have to do is plug all of these in and put it into a calculator. P equals 45 times E to the 0.04 times 6. And that would be 57.2 bacteria. The next example is dealing with a continuous exponential decay. The mass of a radioactive substance follows a continuous exponential decay model. The sample of this radioactive substance has the initial mass of 694 kilograms and decreases continuously at the relative rate of 11.2% per day. Find the mass of the sample after 1 week. So there's a couple of keywords here. Let's go ahead and point them out. So it is the exact same formula as in the previous example. The initial amount is 694 kilograms. The rate at which the substance is decaying is 11.2%. Turn it into a decimal, 0.112. However, it is a decay, it decreases, so we need a negative in front of it. And then time, that's 1 week, but a sample is decreasing at a relative rate of 11.2% per day. So when we're doing T at 1 week, our units do not match with the given units in the problem, so we have to convert them. There's 7 days in 1 week. Now that we have taken care of all of the given stuff, we just need to put it into the formula and then put it into a calculator. 694 times e to the negative 0.112 times 7. And that would be 316.9 kilograms. Number 3, the species of animal is discovered on an island. Suppose that the population of this species is modeled by the following function. T is measured in years this time. What is the initial population size? And we're going to round to the nearest whole animal on this one. So this is population at time 0. So you're actually going to have to plug in T equals 0 and put it into your calculator if you cannot do it without. So that is 120 animals. And then part B, what is the population size after 5 years? All the same things, just T is 5 and not 0. You put that into your calculator, that is 396 animals. And then number 4, which is the last example on this one, the initial amount of 3,500 is invested in an account with an interest rate of 8.75% compounded continuously. Assuming that there's no withdrawals, find the amount in the account after 7 years. So the banking formula for the growth or decay, continuous growth or decay, looks similar to our normal formula. P, it's not P naught in this formula, it's just P, and then e to the RT, where R is the same thing as K was in the previous examples. So P is the initial amount still, which is 3,500. R is the rate at which the money is increasing in this case, so 8.75% or 0.0875. And then T is 7 years. After that, just put it into the formula. So 3,500 times e to the 0.0875. Don't truncate any of the numbers. And then times 7. So this time it's money, $6,457.63.